Hello children, let's come back to our maths class. In the previous class we have dealt with some problems from exercise 7.8. We have only one sum left in exercise 7.8 which will be seen today. So take down your classwork, write down today's date, copy down sum number 12 from exercise 7.8. Copy down question number 12 from exercise 7.8. Okay, take down the question. A hollow core with base radius A centimeter and height B centimeter is placed on a table. Show that the volume of the largest cylinder that can be hidden underneath is 4/9 times volume of the core. So, it's a question here. A hollow core with base radius A centimeter and height B is placed on a table. So, what you have? You have a hollow core. Hollow core means there is a space inside the core. So, we will draw a figure, a core. We have a hollow core which is placed on the table. So, this is placed on a table. And what is the base given here? The base is taken as A, that is the base radius. So, the radius is A centimeter. So, just put here A. And what is the height given here? It is B. So, put here height as B centimeter. So, this is for core. Okay, for core, the radius is A and the height is B. And they are the constant value. You cannot change the radius and you cannot change the height. So, they are the constants here. We cannot change the value. So, I have just given the detail for core. So, for cone, we have the radius as A and the height as B. Okay, now what else is given to you in the question? They say that show that the volume of the largest cylinder, that means the function here is taken as the volume of the largest cylinder. That is, you have to find out the volume as the function. That can be hidden underneath. That means you have to place a cylinder under the core. So it will be like this. You will get a figure for the cylinder somewhat like this. Try to draw a figure of cylinder. So you have a core and underneath the core what is present? A cylinder is present. So this full length is here. Okay. This is our base radius. And this is the height of the core. Now I have to talk about the radius of the cylinder. That is, I will take this capital A and I will take the height of the cylinder as capital B. And for cylinder, the radius is A and the height is B. This is the cap. Okay, and this cylinder, see, suppose this is a cone. I have told you that the radius of the cone and the height of the cone will not change, they are constants. But talking about the cylinder, I can just change the radius of the cylinder and the height of the cone. We can just have different figures. So, they are not constants. Okay, they can be changed. So, they can be changed. So, down for cylinder, the radius is A. And the height is B. I am just going to give some namings over here. I will take this as P. I will take this as Q. I will take this as R. Take this as S. Take this as T. And this is 90 degree here and this is 90 degree. Just mark P, Q, R, S, T. You just mark P, Q, R, S, T. Have you drawn the figure? Have you named all the parts? So, P, Q, R, S, T. Okay, now I am going to consider two right angle triangle. Write down here. In triangle, in triangle PQS and triangle, see I have taken this PQS, I have taken this one triangle and I am going to take triangle PRT and triangle PRT. I have taken this two triangles and I am going to show similar, these two triangles are similar. So now just see here, P is common to both the triangles. So I put here angle P is equal to angle P, this is common angle. Then one more thing I can say that this is 90 degree, this is 90 degree. So angle PQS is equal to angle PRT. Put here angle PQS is equal to angle PRT. This is equal to 90 degree. So now we have just shown two conditions related to angle. This is angle, this is angle. So I'll say that triangle PQS is similar to triangle PRT. You can write down here by AA similarity. In triangle PQS and triangle PRT, we have angle P is equal to angle P, which is common. Then angle PQS is equal to angle PRT, is equal to 90 degree. And I got two conditions on angle. So I'll say that the triangles are similar using AA similarity. Okay. Now let's see, we'll write down the corresponding sides over here. So what I'm going to do is, I'm just going to write down the corresponding sides over PQ. This is the height, okay. I'll take the height and I'll take the radius part, that is QS. So put your PQ upon QS and same procedure you follow here. So I'll get here PR, see the height is PR and the radius is RT. I'll get here PR upon RT. I'm just going to substitute the value. So what I get here, PQ. What is PQ? This is PQ part, this here. This full line is PR and here you have Q, yes. So the height of the cone, this full part, this is the height of the cone is B. And what is the height of the cylinder? It is capital B. So you have this one. I know the full height as B and the height of the cylinder is capital B. So what will be this height? This will be B minus B. See, I have just shown you the explanation over here. So we know that the full height is capital B and I know that from Q to R it is, full height is small b and from Q to R it is capital B. So what is the height of PQ? It is from small b, you are going to remove capital B. So B minus B. Okay. So what I get here, PQ is B minus B. What is QS? Yeah, QS is capital A. And what is PR? PR is small b. And what is RT? RT is small a. So now just get the answer in terms of A. So I get A is equal to A into B minus B upon B. A is equal to A into B minus B upon B. A is equal to A into B minus B upon B. Okay, done. So we have found the value for A. So we have just proved the triangles are similar and we have just found the value for A. Now what are we going to do here is we are just going to define the function. So what is the function here? Volume of the largest cylinder. That means I am just going to talk about the volume of the cylinder. So write down here, let Fx is equal to volume of the cylinder. That is, what is the formula for volume of the cylinder? Pi r square h. Just mention here pi r square h. Pi r square h. Now I am talking about the cylinder. So what is the radius of the cylinder here? The radius of the cylinder is capital A and the height of the cylinder is capital B. So I just replace in terms of A and B. So I'll get this is equal to pi a square b. I'll get it as pi a square b. Okay, done? So now what we are going to do is we are just going to substitute the value for a, because do not keep two variables. We have to just keep it as a single variable. So I'll get this is equal to pi a square. So this is, I'll just directly write down the value. So a will turn to a square, b minus b the whole square upon b square into b. So this is what I get. Pi a square. So a square, b minus b the whole square upon b square into b. I'll take the constants. I have told you that a and b are constants. So I'll take the constants. I get this is equal to pi a square upon b square. And you have your b minus b the whole square into b left out. This is our function. This is the fx part. So f of x is equal to pi a square upon b square, b minus b the whole square into b. So this is our function. We have found the function. Now what is the next step? Yes, we have to find out f dash x. After finding f dash x, we have to equate it with equal to 0. Let's do the step. I'll just continue the step over here because it will be very late. I'll just start here, continue. I'll take f dash x. I'll just continue that step here. We have f of x is equal to pi a square upon b square, b minus b the whole square into b. Okay. Now we have to find out f dash x. Just see here how to find f dash x. Keep the constant term as it is, pi a square upon b square. And now we are going to use uv rule over here. So u dash v plus v dash u. What is uv the whole dash? It is u dash v plus v dash u. So u dash. So b minus b the whole square. So this becomes 2. The 2 will come to the front. I'll get b minus b the whole raised to 1. And you have to take the derivative for b, because b is a constant. So I'll get 0 answer. But for this you will get minus 1 into minus 1. So u dash is done. V. What is V? It is B. So put here B plus V dash. What is the derivative for B? It is 1. What is U? B minus B the whole square. I'll explain to you once again the derivation. The state of the step I'll explain to you. So U V dash, that is u dash v plus v dash u. So u dash. So this is x square. X square, what do you get? 2x's. So we have written down 2 into b minus b. And you have to take the derivative for minus b. So derivative for minus b is minus 1. So v is b as it is plus u v dash. What is the derivative for b? It's 1. And u, what is u? B minus b the whole square. Okay. So this is what we have found the answer for f dash x. We'll try to simplify this further. So I get this is equal to pi a square upon b square. Now let's see here, b minus b, small b minus capital B can be taken common. So I take b minus b common. So what I left? This is 2 is left, minus b is left. So it is minus 2b. 2 into minus 1 into b. So minus 2b. And here 1 b minus b is taken out. So 1 b minus b is left. Small b minus capital B. So this is plus b minus b. Okay. So this is equal to pi a square upon b square. B minus b. This is minus 3b plus b. Okay children. So this is what we get. When you differentiate f of x, that is f dash x is equal to pi a square upon b square. B minus b minus 3b plus the state of the steps. Okay, completed children. So now what we are going to do here is, we are just going to equate f dash x is equal to 0. That is the next question. You know how to do this one. So f dash x is equal to 0 implies, now this is a constant part, when it goes to the right hand side it will become 0. So I get b minus b is equal to 0 or minus 3b plus b is equal to 0. So b is equal to b or minus 3b is equal to minus b. So minus minus will get cancelled and b is equal to b upon 3. So these are the two values I get. I get the value for b as b. The small b is equal to b, or I get b is equal to b upon 3. Now this is not possible. I cannot say that the height of the cone and the height of the cylinder are same. We cannot have the height of the cone and height of the cylinder as same. If you have the same height for the cone and the cone, that condition is not accepted. This is not applicable. It's not applicable because we cannot have the height of the cone and height of the cylinder to be same, because the cylinder is present inside the cone. That means the cone will be of greater height. So we cannot have this statement. So I have to take the value for b as b upon 3. So I have found the value for b as b upon 3. So using f dash x is equal to 0, I have found the value for b as b upon 3. Okay, completed. Now let's go for the next step. Now you know what to do. We have to find out f double dash x. Yes, find out f double dash x. So I will continue here. I get here f double dash x is equal to. See here, I will start from here. And I will take from here. So this is pi a square upon b square. You will keep it as it is. So that's pi a square upon b square. Now b minus b. B minus b means this is again u v rule. So u dash v plus v dash u. So u dash. So what is the derivative for this? It is minus 1 because you have only minus b here. Yes. So I get here minus 1. Then v you have to write down as it is. It is minus 3b plus b. Okay. Plus v dash. What is v dash? This is minus 3. And here this will become 0 because b is a constant term. And what is u here? B minus 3. So this is what you get for u dash b. Just write on the derivation. I get minus 1 minus 3b plus b minus b into minus 3. They clear with this children, u dash v plus v dash u. So what is u dash? Minus 1. V as it is you have written down. V dash now minus 3 into 1. So minus 3 and you have written u as it is. So it is minus 1 minus 3b plus b plus minus 3b minus b. Actually from f double dash next we come to know whether the function is maximum or minimum. But here this is not giving you any detail whether it's positive or negative. So what I am going to do is I am going to substitute the value for b, that what we have found. We have found the value for b as b upon 3. So we are just going to substitute over here. So I get this is equal to pi a square upon b square minus 1 minus 3. In place of b you have to put small b upon 3. So I get b upon 3 plus b plus minus 3 b minus b upon 3. Okay, so I have just substituted the value for b upon 3. In place of capital B I am just going to put it as b by 3. So this is equal to pi a square upon b square as it is. This is minus 1. I'll just do the calculation. Minus 3 and minus 3 and 3 gets cancelled. So minus plus b will give you 0. So the whole term gets 0. And what is left here now? Minus 3. This is 3b minus b. 2b upon 3. 3 into b, 3b minus b, 2b upon 3. So see here. So we have your minus sign. Yes, student. Since we have your minus sign, we can just say this is less than 0. Therefore, it is maximum. because we have to find out the volume of the larger cylinder. So we have to show that it is maximum. So we have shown that it is maximum. Just take all the steps. No need to simplify it further. Only the thing is we have to check it out whether it is positive or negative. Yeah, it's negative, so I can say it is maximum. So the next thing is we have to show that. See the last statement. We have to show that volume of the largest cylinder that can be hidden underneath, that is present inside the cone, is 4 upon 9 times volume of the cone. So this is what you have to show. So we have just found the function, we have found f dash x, we have equated with 0, we have found the critical value. After finding the critical value, you have found f double dash x, and using the critical value I have found that it is maximum. Now coming to the proof part, we have to show that 4 upon 9 times volume of the cone. Let's see how to go with that step. So what I am going to do is, I am just going to take the function as it is. So what is the function given to us? It is f of x is equal to pi a square upon b square, b minus b the whole square into b. Okay, this is the function. I am going to take the function and I am going to use the function to get the proof part. Then here f of x is equal to pi a square upon b square, b minus b the whole square into b. This is what is the function that we have found, pi r square h. Now what I am going to do is, I am just going to use the critical value here, that is b upon 3. So I will put here f of b upon 3 is equal to pi a square upon b square. In place of capital B, you have to put a small b by 3. Okay? So b minus b upon 3 the whole square into b by 3. I get pi a square upon b square, b minus b upon 3 the whole square into b upon 3. So we have to just simplify this further. So what you get when you simplify? I get this as pi a square upon b square as it is. See here, this is 3b minus b, 2b upon 3. So 2b upon 3 the whole square. This is 4b square upon 9 and it is b upon 3. I've just found the answer for this part. 3b minus b, 2b upon 3, that is 4b square upon 9 into b upon 3. So we get pi a square upon b square, b minus b upon 3 the whole square into b upon 3. So I get the answer is pi a square upon b square, 4b square upon 9 into b upon 3. So now we are just going to arrange this in a proper order. Let's see. So actually what is this? We started with the volume of the cylinder. So we have started with volume of the cylinder and you have to show this is equal to 4 upon 9 times volume of a cone. Okay. So this is what you have to show. So let's see how to show further. So we'll just arrange it properly. So let's arrange this. So again this is equal to pi a square upon b square as it is. Take 4 upon 9 separately and 1 upon 3 also you take separately. So now what is left here? B square and b square we can cancel. So only b is left. So I write this as 4 upon 9, 1 upon 3 pi a square. I have cancelled b square, so only the thing left out is pi a square and here 4 upon 9 is left and here 1 upon 3 is left and here b is left. So this is 4 upon 9, this is 1 upon 3 pi r square h. A denoted the radius of the cone and B denoted the height of the cone. So this is equal to 4 upon 9 volume of cone. So what we started with? We started with the volume of cylinder. So what I get? Therefore, volume of cylinder is equal to 4 upon 9 times volume of core. Hence, proved. Hence, proved. So, we have proved our sum. So, volume of cylinder is equal to 4 upon 9 times volume of core. So, we have proved our sum number 12. This was the last sum from exercise 7.8, and I think we have completed our unit 7. Okay, we don't have 7.9 for the portion that's a reduced syllabus. So, with this we complete our unit 7, and now we are going to start with unit 8. So, I just want all of you to take your maths textbook and you are just going to take unit 8, the next lesson, and we are going to continue with exercise 8.1. So, when you start with a new unit, take a new page and write down today's date, write down the name of the lesson, and just start with exercise 8.1. Start with lesson number 8. It is differentials and partial derivatives. Give the heading as differentials and partial derivatives and go for exercise 8.1. Take on the first sum, let f of x is equal to cube root of x. Find the linear approximation at x is equal to 27. Use the linear approximation to approximate cube root of 27.2. So, this is what is your question. They have given you f of x. They are asking you to find the linear approximation at x is equal to 27. And they are saying that using the linear approximation, you have to find out the value for cube root of 27.2. So, let's see how to continue with this sum. So, just take down the answers. Start with the answer part here. This is 8.1, sum number 1. Okay, here we are talking about the linear approximation. So, write down the formula for the linear approximation. Write down L of x is equal to f of x naught plus f dash x naught into x minus x naught at x is equal to x naught. X naught. So, this is the formula that we are going to use. They have asked you to find out the linear approximation at x is equal to 27. So, we are just going to use this formula to get our answer. Okay, children? So, write down L of x is equal to f of x naught. L of x is equal to f of x naught plus f dash x naught into x minus x naught at x naught. Okay, now let's see how to continue further. Let's see what is given to us and what to find out here. Let's start with the sum. Write down. Let fx is equal, already they have given the fx part, so write down here. Let fx is equal to cube root of x. So, cube root of x. So, this can be written as x raised to 1 by 3. So, this is our function. Now, what I am going to do is, I am going to find out f dash x. Okay, we have to change this in terms of x naught later, and then x step will change it. But before that, we find out f dash x. So, what is f dash x here? Now, x raised to 1 by 3. This is in the form of x raised to n. So, you have to put n to the front. So, 1 by 3 will come to the front. Write down x and 1 upon 3 minus 1. So, 1 upon 3 minus 1 is 1 minus 3 upon 3. So, minus 2 upon 3. I get this is equal to equal to 1 upon 3 x raised to 1 minus 3 upon 3 minus 2 upon 3. So, this is a negative power. So, if I bring this to the denominator part, I get a positive power. So, I write down this is 1 upon 3. I am going to take this term in the denominator. So, I will get x raised to 2 by 3. So this is f dash x. So I have found f of x, and using f of x I have found f dash x. That is 1 upon 3x raised to 2 upon 3. Okay, done. So now what I am going to do is I am just going to change this in terms of x naught. So what I get here, I get f of x naught is equal to x naught raised to 1 by 3, and I get here f dash x naught is equal to 1 upon 3 x naught raised to 2 by 3. So I have just changed x in terms of x naught. That's all. This is the step. F of x naught is equal to x naught raised to 1 by 3. F dash x naught is equal to 1 upon 3 x naught raised to 2 by 3. Okay, now what I am going to do is I am just going to substitute this in the formula part. I'll get here, therefore L of x is equal to x naught raised to 1 by 3 plus 1 upon 3 x naught raised to 2 by 3 x minus x naught at x naught. With the substitution, so I get L of x is equal to, very easy step to do. So we have f of x, we are finding f dash x. I have written the linear approximation formula. Now I am changing f of x as f of x naught, and I am changing f dash x as f dash x naught. Same thing, only the thing is the x will be changed at x naught. Okay, now I have written the formula part over here. Now what I am going to do, they are saying that find the linear approximation at x is equal to 27. Find the linear approximation at x is equal to 27. So we are just going to replace this value as 27. So what is the value for x naught? We are going to take it as 27. So just replace it. So what I get here, L of x is equal to 27 raised to 1 by 3 plus 1 upon 3 27 raised to 2 by 3 x minus 27. See, I have just substituted the value in place of x naught. I have written 27. Now let's try to simplify this further. So this is 27 can be written as 3 cube. 3 9s are 3 3s are. So I get 3 cube. So this is 3 cube raised to 1 by 3 plus 1 upon 3 cube raised to 2 by 3 x minus 27. Okay. So 3 gets cancelled. This is 3 into 2 by 3. So again 3 gets cancelled. So what is left now? 3 plus 1 upon 3 is here, and this is 3 square. So 3 square 9. 9 3s are 27. X minus 27. Okay, so just cross multiply this. I get 21, 2 6, 81. I get this is 81 plus x minus 27 upon 27. So what is 81 minus 27? 54 plus x upon 27. So this is our linear approximation. So L of x is equal to 54 plus x upon 27. We have just completed the first part of the answer. Find the linear approximation at x is equal to 27. So at x is equal to 27, the linear approximation is 54 plus x upon 27. So I found the value for L of x, that is 54 plus x upon 27. I hope you are clear with the steps, children. So we have found the value for L of x, the linear approximation. Now what we have to do is we have to find out the linear approximation at cube root of 27.2. That means you have to substitute the value for x is 27.2. That's all. So write down. Therefore, L of 27.2 is equal to 54 plus 27.2 upon 27. (81.2) upon 27. I get 81.2 upon 27. So we are just going to simplify this further. 27 and this is 81.2. 27, 3s are 81, 0, will not go, so 0. I put 0, again I'll get 0. Again I put 1 0. So now 27, 6 are 42, 16. 7 is 49, 14, 18, 8 7 8 are 56. It goes above this. So I can take 7. It will be 3.007. And how much I get? 7 7 are 49, 4, 189. So this is 1, 1, 11. If I put here 0, 81, 4s are 28, 10, 108. I can take this value, so 4. Around 3.007. So you get the answer approximately as 3.0074. This is the answer. So the answer is 3.0074. So we have completed the first sum. The answer is 3.0074. Just remember the procedure. We have to just follow the same procedure for the remaining sums also. Wherever you are dealing with the linear approximations, we are just going to go for the second sum. Take down question number 2. Take down sum number 2. Copy down question number 2. Use the linear approximation to find approximate values of 123 raised to 2 upon 3. Take down the second question. Use the linear approximation to find approximate values. Okay. So again here we have to use this formula and we have to get the answer. So write down sum number 2. Write down the formula. L of x is equal to f of x naught plus f dash x naught into x minus x naught at x naught. Okay. This is the formula. Take down the formula. Take down the formula. L of x is equal to f of x naught plus f dash x naught x minus x naught at x naught. Okay, done. So now let's continue this further. Let me write down what is the next thing here. I am going to take the function. The function is given to us as 123 raised to 2 upon 3. So write down. This is the question. Yes. Now that f of x is equal to x raised to the power. In terms of x, we are not taking the value. I am just taking the answer in terms of x. So I have taken x raised to 2 by 3. So you know what is the next step? You have to find out f dash x. Take 2 upon 3 to the front. X you write down as this 2 upon 3 minus 1. 2 upon 3 minus 1. 2 minus 3 upon 3. So it's minus 1 upon 3. So you can bring the negative power in the denominator. So I get 2 upon 3 x raised to 1 upon 3. So I have found f dash x. I have found f of x. Okay. Now what we are going to do? After identifying the function, so do not write 1 upon 23 raised to 2 upon 3. We cannot do anything with this sum. We cannot do anything. We cannot differentiate this. So you have to just write down it as x raised to 2 by 3. Okay, children? Now, we are just going to change this in terms of x naught. So I get this as f of x naught is equal to x naught raised to 2 by 3. And this will be f dash x naught is equal to 2 upon 3 x naught raised to 1 by 3. Okay, done? I get is x naught 2 by 3 and f dash x naught is 2 upon 3 x naught raised to 1 by 3. Now what I am going to do is I am going to take the value for x naught. Here A we took 27 and the first sum we took 27, and then after finding the linear approximation using 27 we found the answer for 27.2. So now here we are not going to take 123 directly because we cannot find anything related to 123. So if instead of taking 123 I am going to take the closest cube to it. So I can write it as 125. If I write 125 I get that as 5 cube is 5 into 5 into 5, so it will be 125. So I am just going to write 125. I will not write 123. Instead of 123, what I am going to take? I am going to take the closest number, that is 125. So write down, substitute x naught is equal to 125. Okay, after finding the answer for 125, I will find the answer for 120 because we have to find out the answer for 123 raised to 2 by 3. So I will take now 125. So just substituting the formula, I get L of x is equal to f of x naught. That is, in place of x naught, what are you going to put? 125. So 125 raised to 2 by 3 plus f dash x naught. That is 2 upon 3. 125 raised to 1 by 3 x minus x naught. So x minus 125. This is what I get. So I get L of x as 125 raised to 2 by 3 plus 2 upon 3, 125 raised to 1 by 3 x minus 125. Okay, let's try to simplify. I have told you this is 5 cube. Yes, 125. 5 2s are 10, 2, 5, 5, 5. So you can just replace this as 5 cube. So what I get here? L of x is equal to 5 cube raised to 2 by 3 plus 2 upon 3 5 cube raised to 1 by 3 x minus 125. Go with the substitution. So I have just substituted the value for x naught as 125 and I have written 125 as 5 cube. Okay, now we are just going to simplify this further and see what we get the value for L of x as. So this is 3 gets cancelled here, 3 gets cancelled. So this is 5 square, that is 25. This is 2 upon 3 goes off. So this is 5 and this is 3. So I get 15 x minus 125. Let's open the bracket. So this is 25 plus 2x minus 250 upon 15. Say on the step. You have just multiplied this, we have not cross multiplied. So I get 25 plus 2x minus 250 upon 15. Okay, so now we are just going to expand this. Let's see what we get when you multiply this two. $375 plus 2x minus 250 upon 15. 125 plus 2x upon 15. I get 125 plus 2x upon 50. So this is the LX. I will just continue here. I will just write down here. Therefore, L of x is equal to 125 plus 2x upon 50. This is what I get. Complete L of x. Okay, now we are just going to continue further. I am going to find out the value that is given to us. We have to find out 123 raised to 2 by 3. So write down therefore L of 123 is equal to 123. Yes, this is 125 plus 2 into 123 upon 15. I have just substituted the value plus 246 upon 15. 125 plus 246 upon 15. Add these two values. 11, 6, 7, 3, 71. Now we have to divide this and we have to get the answer. 15 2s are 30, 15 4s are 60, 110. So closest to 110. 7s are 15 7s are 105. Yes. 15 7s are 105. So 5. Yeah. 5. 0. So 15 2s are 15 3s are 45. 5. It will go on 24.7333 goes on. So you can just say this is approximately to 24.733. See, this is the answer. 24.733. Here are the answer. So we have completed the first subpart of sum number 2 and the answer is 24.733. Okay. So I just wanted to give some homework. The homework will be from question number 2, the second subpart and the third subpart. You are going to complete these two sums as homework. And along with these two sums, you are going to complete question number 3, first subpart, second subpart and third subparts. Complete this 2 questions as your homework. Question number 2 and question number 3. From question number 2, the second subpart and third subpart will be homework, and from question number 3 you have to complete the third. From question number 3 all the three subparts. From question number 3 all. I hope you have completed your previous homeworks. Complete all your homework.